starting now, okay? We are doing the last part of first chapter, article 1.14, which is measurement of time and simple pendulum. Okay, so we quickly start without wasting any time. We start by understanding what is a simple pendulum. A simple pendulum is a heavy point mass which is suspended from a rigid support, okay, by a massless and inextensible string. Okay, so it's a heavy point mass. A mass which is the size of a point is heavy, and then it is suspended using a string. The string is massless. The string doesn't have any mass and it is inextensible, which means it cannot be extended. Okay, so practically it's not possible. It's an ideal situation. But we know that all the masses, they have their entire mass centered around a point, okay, which is known as the center of gravity. Okay, so we can treat all masses as point masses which have the entire mass concentrated at this point, the center of gravity. Okay, it's not possible for us to have a string which is massless and inextensible. I have made a simple pendulum. This is how it looks. Okay, it has a heavy point size mass which is suspended using a inextensible massless string. Okay, so we have this pendulum. We have been using a pendulum since ages to measure time. Now if I displace it from its mean position, and I leave it, then you see it starts oscillating. It goes from one side to the other and continues. The resistance offered to it by ear is very less, so it continues to oscillate, right? It continues to oscillate. So let's, now that we have understood what a simple pendulum is, let us understand some of the terms which are related to a simple pendulum. Okay, first of all, I said it starts oscillating, oscillation. So what is oscillation? Now this is the rigid support S, okay, and this mass is known as the bob of the pendulum, right? So we measure its length from its center of gravity. Of a sphere, the center of gravity is at its geometrical center, right? So from the geometrical center to the rigid support, whatever the length is, L, that is known as the effective length. Okay, now if I disturb this, then this bob goes first that side to B, okay, then it comes back and goes further to A. Okay, it gains inertia and then it continues. Okay, then it, from here it comes to a standstill for a moment, and then it again starts back, so it comes back here. So this is one complete oscillation, one complete to and fro. When it started from O, it went from O to B, okay, then it went from B to A, and then finally back from A to O. Okay, we could take it the other way around also. It starts from O, comes to A, okay, then from A it goes to B, and finally from B it comes to O. So that makes one complete oscillation. There is another way also. Okay, when I disturb it, generally I bring it to one side. Okay, मैं एक तरफ ले आता हूँ जब भी मैं इसको disturb करता हूँ, तो मैंने इसको मान लो ऐसे disturb कर दिया, A पे ले आया. A पे लाने के बाद जब मैं इसको छोड़ता हूँ, तो ये A से O जाता है, O से B जाता है, फिर B से होता हुआ वापस A आ जाता है. Okay, so it started from A, once it is back to A, that is one complete oscillation. It could be the other way around also. It could be from B also. Okay, I disturb it towards B. Now this is its position. I lower the length of the string. Okay, this is its position. I bring it to A. Okay, I bring it to A and I leave it, and there it is going to B and coming back, going to B and coming back. So if I have to count the oscillations, okay, when it comes back, I start counting. There I leave it. Now I start. Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so the position from where I had started, there when the bob comes back, I take that one oscillation has been completed. Got it? So everybody understood what oscillation is. Okay, and next we go to time period. Okay, now the time taken by it starts from here, okay, and goes to B, then comes back to A. Then the time taken by it to complete this one complete oscillation is known as its time period. Got it? We denote it by a capital T. So T is time period. T is time period. And what is it? It is the time taken, okay? It is the time taken to complete one oscillation. Which means if it starts from A, then goes to B and comes back to A, whatever time it takes, that is denoted by a capital T, and we call it the time period. Okay, now the next thing we go is we go to find the frequency. I take this pendulum, I disturb it, okay, and 1, 2, 3, 1 second up. So I counted that it oscillated 3 times within a second. Okay, on one hand I have my stopwatch. On one hand I have my stopwatch, okay, which is on my mobile. So I am using the stopwatch of my mobile. Got it? I'll show it to you. Here, this is the stopwatch. Okay, I started and okay, 3 seconds, 4.6 seconds. So I just counted, and by the time it completed 1 second, the pendulum had completed 3 oscillations, which means its frequency is 3. Okay, so the number of oscillations which a pendulum completes in a second is known as its frequency. I'll read out your book's definition. Okay, frequency of oscillation. It is the number of oscillations made in 1 second. And how do we denote it? We denote it by a small f or a n. Okay, we denote it by a small f or a n, and its unit is per second. Second inverse, it's also known as hertz. Okay, it's also known as hertz. Its time periods is second. Time periods SI unit is second. Right? Now there is a relationship between the time period and the frequency. There is a relationship between the time period and the frequency. Okay, if T is the time period of a simple pendulum, then it means that in T seconds it oscillated once. Okay, in T seconds it completed one oscillation. So how many oscillations will it complete in 1 second? Then it becomes unitary method 1 by T. Okay, and we know that the number of oscillations which it does in 1 second is the frequency, right? So the frequency becomes the reciprocal of the time period. That's a relationship. That's a relationship between the time period and the frequency. Everybody got it? I can cross multiply and I can write it vice versa also. It can also become T is equal to the reciprocal of the frequency. I can write it both ways. So this is the relationship. Let me read out what your book says. Book says that if T is the time period of a simple pendulum, then in T seconds the pendulum oscillates once. Whatever I said, it's the same thing. Nothing else is given over there. Okay, now who has come? Shubham Yadav. I explain once again frequency. Okay, Shubham, sure. I'll explain to you the frequency once again. Okay, now Shubham, see, now I have a pendulum over here. Okay, and I will start my stopwatch immediately, and as the pendulum starts oscillating. Okay, so we'll get to know how many times it is oscillating. Okay, in a second. So now I disturb it and I stop my stopwatch. Okay, now when it comes to this end, then I start counting, and then it is then that I start my stopwatch. So it comes here and I started 1, 2, 3, 1 second up. Okay, so it completed 3 oscillations in a second. Got it? which means that its frequency is 3. Okay, had it completed half a oscillation, okay, suppose I say that I increase the length and I disturb it over here and it goes there and comes back, and I see that it has completed one oscillation in 2 seconds. No, one oscillation in 1 second. Okay, it could do one oscillation in 1 second, right? Then its frequency is 1, right? If it does one oscillation in 2 seconds, then its frequency is half, 0.5. Got it? Which means the number of oscillations done, I note down the number of oscillations which is done. Suppose I started, okay? I started and I now switch on my stopwatch and now I'm noting the time, okay? And I start switch on, there we go. Now 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. I stopped my stopwatch, okay? And now let me check the time. Let me check the time, and I see that it has taken, how much time did it take? It, for 10 oscillations, it took 24 seconds, okay? 24 seconds. So if I divide 24 by 10, it means 2.4 seconds was the time taken for each oscillation. Okay, so what is the frequency? That is the time period. Got it? So if I know the time period, I divide 1 by the time period and I get the number of oscillations which it will complete in 1 second, which will come in decimals. Clear, Shubham? Shubhi, sorry, Shubhi. Shubhi, understood? Perfect. Very nice. Okay, we move forward now. So we have understood the time period, we have understood the frequency, we have understood the relationship between time period and frequency. I've also told you the effective length. Okay, what is the effective length? See, in this case, I was holding it from this place, right? So if I measure the length, then the length comes out to be 29 centimeters. You can see that the length of the thread is coming out to be 29 centimeters. But when I add the diameter, okay, when I add the radius, okay, of the bob, then it comes to 30 centimeter, which means my effective length was 30 centimeters. So I measure it from the center of gravity. How can I do that? I can, how do I find the diameter? I can find out the diameter using a vernier calipers. I slide it in a vernier caliper, find the diameter, divided by 2, I get the radius, add the radius to the length of the thread, and that is my effective length. Okay, so let me read it out for you. What is the effective length? It is the distance of the point of oscillation O. This is the point of oscillation, the center of gravity, okay? It is the point of oscillation O, that is the center of gravity of the bob from the point of suspension. This is the point of suspension and this is O, the center of gravity. The length between them, which means the length of the thread plus the radius of the bob, will give you the effective length. Understood, Shubhi? Okay. Okay, now we go to measurement of time period of a simple pendulum. I have already told you how to find the time period of a simple pendulum. Okay, I don't know if Shubhi was hearing or not. Okay, so I repeat it once again. Okay, to measure the time period of a simple pendulum, the bob is slightly displaced from its rest position. Okay, so now this is the bob, I displace it. Okay, this is its rest position. Ideally it will be at the center. Now what I do is I disturb it. I disturb it from its rest position and then I let it go. Once it starts swinging, it comes over here and I start my stopwatch. Now I'm counting in 20. Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. I switch off my stopwatch. Okay, so for 20 oscillations, what was the time? I look at the stopwatch and it says 20 seconds. Okay, let me make a table for this. So we continue doing this and you'll understand also. I can erase all this. Okay, we make serial number. This is 1. Then we took the length L in centimeters. The first one we took was 25 centimeters. Okay, then time for 20 oscillations. It was, we noted it, it came to be 20 seconds. Okay, then we find time period. Look at this, we denote with T. So this T is equal to T by N. Okay, so in this case T becomes 20 by 20 is equal to 1 second. Okay, what it should be. So that is how we found the time period. I started my stopwatch and I stopped it and I kept on counting the number of oscillations. Okay, I had measured the length, the effective length. In the first case, I had taken it to be 25 centimeters. Okay, in the first case, I had taken it to be 25 centimeters and I saw that it exactly took 20 seconds to complete 20 oscillations. Got it? So that's what I note over here, 20 seconds for 20 oscillations. Okay, 20 oscillations. Okay, the length which we had taken was 25 centimeters. So what is the time period? If this was T, total time I denote by T, then I divide this by the number of oscillations. So I divide the total time by the number of oscillations. The total time which I got was 20 seconds. I divided by 20. So the time period of the simple pendulum was 1 second. Understood? Easy? Okay. Now what I do, I change its length. Okay. Now I increase it. How much do I increase? First I take, this is 30 and then I put another 6 over here. So this becomes 36. Okay. So now the length is 36 centimeters. Okay. I again start my stopwatch. Where is it gone? I start my stopwatch. I reset it. Okay. And I will start it when I start counting. Okay. So, and I disturb it, leave it, and we'll start counting. Yeah. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Okay, so I stopped it at 20 and the stopwatch shows 24 seconds. It's while stopping, a minor error was there, my reflection, it didn't stop on the first. So it was 24 seconds. Got it? So now I write second when my length is 36 centimeters, then the time for 20 oscillations were 24 seconds. So what is the time period? The time period is equal to 24 divided by 20, okay, which is 1.2 seconds. Got it? So when I increase the length, the time period increased. Clear, Shubhi? You're understanding now? So when I increase the time period, when I increase the length, its time period increased. Now I increase it further. This time I make it 49. This is 30 and I make it 19. Okay, so now it is 49. What Shubhi says, sir, please share the app for vernier calipers. Yeah, I forgot about that. I'm so sorry. Today I'll definitely do. Okay, you send me a WhatsApp. I'll remember. You send me that, sir, please send me the virtual vernier caliper and screw gauge. I'll immediately do it. Otherwise I forget, so busy these days. I'll do it definitely today. Okay, if I remember, good. Otherwise you remind me once. Okay, so now what I do is, now I have made the length 49 centimeters. This is my third reading and I have changed it to 49 centimeters. Okay, I reset my stopwatch. Come on, where are you going? Stopwatch. Okay, reset it to 0 and I will start it again. Okay, now I bring it, my hand is a rigid support, I disturb it and I leave it, and here we start. Oops, it didn't start. Wait, we'll start again. Okay, I disturb it and it goes, and there we start. Come on, it's not starting. Wait, reset and we'll start it, and here we start. Okay, 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15 16 17 18 19 20. Okay, I stopped it at 20 and it gives me a reading of 28.6. My reflexes are slow. Ideally it should have been 28. Okay, so it gives me a reading of 28.6. Some minor errors, my measurement was not exact, my reflexes were not slow, so we write it 28. Okay, I write 28 second was recorded. So what does the time period now become? The time period becomes t is equal to 28 by 20, which means it is now 1.4 seconds. Okay, understood how to find out, Shubhi, the time period? Okay, so now your book already has this table. I'll copy it for the others. Okay, I copy the 4 reading, 4, 5 and 6. And what lengths have they chosen? They have chosen 64 centimeters, 81 centimeters and 100 centimeters. And what is the time noted by them? 32 seconds. Okay, 36 seconds and 40 seconds. Got it? So the time period becomes 40 by 20 is equal to 2 seconds. Okay, this becomes 36 by 20 is equal to 1.8 seconds. This becomes 32 by 20, which means it's equal to 1.6 second. Okay, so what do you observe in this? We note, let me stop close this app now. Stop it, reset, out you go. Okay, we don't need it now, we'll need it later. Okay, so what happens in this, we know that as we are increasing the length, okay, as we are increasing the length, at 25 centimeter it was 1.6, and at 36 it is increased 1.2. I increase further, it increases further, I increase further, it increases further to 1.6, and now I have made it 4 times. Okay, you can see that 100 is 4 times 24, right? So it has become 4 times. So when it became 4 times, what has happened to the time period? जब मैंने अपने पेंडुलम की लेंथ को 4 गुना कर दिया, तब मेरे पेंडुलम के टाइम पीरियड को क्या हुआ? पहले था वो 1 सेकेंड और अब हो गया 2 सेकेंड. सो इट हैज डबल्ड. ओके, तो मुझे इससे 2 चीजें सीखने को मिलती है. पहली तो ये कि मेरा जो टाइम पीरियड है वो डायरेक्टली प्रोपोर्शनल है टू द लेंथ. लेंथ बढ़ेगी तो वो भी बढ़ेगा, लेंथ घटेगी, अगर मैं इधर से शुरू करूं इधर को जाऊं तो लेंथ घटेगी तो मेरा टाइम पीरियड भी घटेगा, लेंथ बढ़ेगी तो मेरा टाइम पीरियड भी बढ़ेगा, राइट? सो द फर्स्ट थिंग व्हिच आई अंडरस्टैंड इज दैट द टाइम पीरियड इज डायरेक्टली प्रोपोर्शनल टू द लेंथ. ओके, द सेकंड थिंग आई नोट दैट कि ये 4 गुना बढ़ रहा है तो वो 2 गुना बढ़ रहा है. ओके, which means what? Which means that the time period is proportional to the root of L. Okay, the root of L, right? समझ में आया शुभी? हाँ ना? What is the relationship given? Over here it is given. Okay, Okay, so we have understood that the time period, first our understanding was this, and finally looking at the length we understood that the time period is proportional to the root of the length. Okay, which means अगर length 4 गुना हो जाती है तो मेरा time period double हो जाता है. ठीक है, अगर मेरी length 9 गुना हो जाती है तो मेरा टाइम पीरियड 3 गुना हो जाता है. अगर मेरी लेंथ 16 टाइम्स हो जाती है तो मेरा टाइम पीरियड 4 टाइम्स हो जाता है. क्लियर शुभी? वेरी नाइस, यू स्मार्ट गर्ल, यू अंडरस्टैंड एवरीथिंग क्विकली. ओके, एंड फ्रॉम दिस वी ऑल्सो कैन से दैट टी स्क्वायर इज प्रोपोर्शनल टू एल. ओके, विच मीन्स दैट एल बाय टी स्क्वायर, which means L by T square is a constant, है कि नहीं? अगर दोनों का रिलेशनशिप ऐसा है कि जब हम लेंथ को हम बढ़ाते हैं तो टाइम पीरियड भी बढ़ता है, और लेंथ को अगर हम 4 गुना कर देते हैं तो टाइम पीरियड डबल हो जाता है. which means दोनों में रिलेशनशिप है कि t square is directly proportional to L. So it means that L by t square should be a constant. वो हमेशा सेम होना चाहिए. ओके, तो लेट्स फाइंड आउट. इस ये जो हमने एक्सपेरिमेंट किया था, हम इसमें देखते हैं कि ये फंडा सच में कामयाब है कि नहीं. ओके, जो हम सोच रहे हैं, क्या एक्सपेरिमेंटली जो हम देख रहे हैं, क्या वो सच में हो रहा है. So I remove this arrows, this arrow I remove, this I remove, and I put in over here. हमें क्या निकालना है? हमें निकालना है L by T square. ठीक है, हमें निकालना है L by T square, और हमारे हिसाब से वो हमेशा सेम आना चाहिए, कांस्टेंट आना चाहिए. गॉट इट? तो हम फर्स्ट केस में लेते हैं. फर्स्ट केस में हमारी लेंथ जो थी वो 25 सेंटीमीटर थी. ओके, और हमारा T क्या आया? 1 आया. तो 1 का स्क्वायर, तो 25 divided by 1 का square is 25 by 1, which means it is equal to 25. Okay, done. We go to the second case. Second case में अब हमारी लेंथ हमने ली थी 36 सेंटीमीटर्स, और हमारा टाइम पीरियड आया 1.2. Okay, which means it is 36 divided by 1.2 into 1.2 becomes 1.44. Okay, so 36 divided by 1.44 again comes out to be 25. तो हमने जो सोचा था वो एकदम सही हो रहा है, दोनों बार वो कांस्टेंट आया. वी गो टू द थर्ड केस. ओके, थर्ड केस, द लेंथ वाज 49 और हमारा टाइम पीरियड आया 1.4. ओके, 1.4 का स्क्वायर, यहाँ पे स्क्वायर नहीं लिखा. ओके, तो 1.4 का स्क्वायर, ओके, विच मीन्स 49 डिवाइडेड बाय 1.4 का स्क्वायर. 1.4 का स्क्वायर कितना है? 1.96. ओके, 1.96, और अगर हम डिवाइड करते हैं तो वो फिर से 25 आता है. Alright, so हम अब ये बिना कैलकुलेशन करें हम इसको भी मान लेते हैं कि 25 आएगा, और हम फाइनल कैलकुलेशन करते हैं लास्ट वाली. ओके, लास्ट वाली में इट इज 100. ओके, 100, और टाइम पीरियड है 2, यानी 2 का स्क्वायर, सो इट बिकम्स 100 by 4, which means again 25. Okay, so what we had thought, it is exactly the same. Okay, तो डिपेंड करता है लेंथ पे. हम जैसे जैसे लेंथ बढ़ाते जा रहे हैं, टाइम पीरियड वैसे वैसे बढ़ता जा रहा है. हम लेंथ को 4 गुना कर दे रहे हैं तो हमारा टाइम पीरियड डबल हो जा रहा है, विच सजेस्ट दैट टी इज डायरेक्टली प्रोपोर्शनल टू, और टी स्क्वायर नॉट रिटन, और टी स्क्वायर इज डायरेक्टली प्रोपोर्शनल टू एल. ओके, गॉट इट? अंडरस्टूड शुभी? Okay, you have your now next class. So I cannot continue. I will have to close it. No, this is the last class. I can continue for some time. Okay, so I'll continue for some time. This is the last class. Okay, so I'll continue for some time. Next, ये सब समझ में आ गया? Give me a yes. Okay, अगर ये आ गया तो फिर मैं तुझे अब आगे लेके जाऊँ. Okay, अब हमें ये समझ में आ गया जो टाइम पीरियड है वो लेंथ के ऊपर डिपेंड करता. हमने उसकी रिलेशनशिप भी निकाल ली कि टी स्क्वायर इज डायरेक्टली प्रोपोर्शनल टू एल, और टी इज डायरेक्टली प्रोपोर्शनल टू रूट एल. ओके, व्हाट अदर थिंग्स इज इट डिपेंडेंट ऑन? ओके, टाइम पीरियड बाकी किन किन चीजों के ऊपर निर्भर करता है. तो नाउ अगेन एक्सपेरिमेंटली वी सॉ कि इट इज proportional, it is inversely proportional to the gravitational acceleration. Okay, which means that T is proportional to 1 by root G. Okay, मतलब अगर हम पहाड़ों के ऊपर जाएंगे, okay, तो what will happen? The gravitational acceleration, will it increase? Will it decrease? Okay, what happens, Shubhi? Tell me. Are you there? Yes, no?
Yes, sir.
Okay, yes. What happens? Yes means what? The value of G will decrease. Mountains पे ले गया तो distance बढ़ रहा है, isn't it? Okay? तो उसका G decrease हो जाएगा. तो अगर G decrease हो गया, which means the time period will increase. Time period increase हो गया मतलब अब oscillation में ज़्यादा समय लग रहा है, right? Which means मेरी घड़ी slow हो गई. Understood? So it is also dependent on the acceleration due to gravity, inversely proportional. If the gravitational acceleration decreases, in cases of when I go up to a mountain, okay, to a higher altitude place, then what happens? The pendulum's time period increases, which means my watch becomes slow. Okay, we did the length, then we missed out on one thing. I'll wind up after this discussion. One simple discussion, okay? I said that that T is directly proportional to the square root of L. Okay, तो winters में चीजें expand करेंगी कि contract करेंगी? शुभी, winters में चीजें expand करेंगी कि contract करेंगी? ठंड हो जाएगी तो आपकी केमिस्ट्री वाली मैम पढ़ा रही थी, I was listening to it. ठंड हो जाएगी तो क्या होगा? चीजें सिकुड़ती हैं ठंड में कि फैलती हैं? She'll answer, don't worry. It takes 6 seconds. She'll answer. In 6 seconds the answer comes. Now I've done the calculations also. In case the child immediately types. Now Shubhi, I'll give you the answer. I'm giving you the answer. Okay, it increases. Okay, no. In winters, yeah. I'm so sorry. I thought summers. You are correct, Shubhi. Winters में it contracts और summers में it increases. The length increases. Okay? तो अब मेरा जो pendulum है, हालांकि वो बहुत छोटा सा contraction या extension होगा, तो क्या होगा? Winters में उसकी effective length छोटी हो जाएगी. अगर छोटी होगी तो time period को क्या होगा? अभी हमने पूरा टेबल बनाया था. Time period कम हो जाएगा. Which means oscillations जल्दी होंगे. Which means मेरी घड़ी तेज चलने लगेगी. तो विंटर्स में मेरी घड़ी तेज चलेगी. समर्स में इफेक्टिव लेंथ थोड़ी सी बढ़ जाएगी. Okay, which means लेंथ बढ़ गई. Which means टाइम पीरियड बढ़ गया. Which means मेरी घड़ी स्लो हो गई. Got it? So during summers and winters, the effective length of the pendulum increases or decreases. In winters, it contracts or decreases. Okay, so the time period becomes slow, so the watch goes fast, whereas in summers the effective length increases. Okay, so the time period also increases and hence the watch goes slow. Okay, that's all for the day. Thank you very much. I'm sorry about the technical errors. Okay, and I'll make up for whatever we lost today in the next class. Please do subscribe to Wisdom 360 channel. Okay, watch the videos there. Go back and revise whatever you think you have missed. Recommend it to your friends also so that they also can be benefited. Thank you very much. Good night.